this question is about binomial expansion, so we have to expand from part A. We have this partial fraction decomposition of the function, and we have to do the binomial expansion 3 times for each term. So for the black term here, so for the term in black first here, 4 over 1 minus 2x, it's the same as 1 minus 2x to the power of minus 1 because of the 1 over. And if you look at 1 minus 2x to the power of minus 1, we can use this formula. Of course, we cannot use this because this is pure 1 formula and the n must be positive, but our n here is negative. So we use the expansion formula 1 plus nx. We have to identify the n. The n is minus 1. The x in the formula is minus 2x in the question, so the minus is included. So this is n, and this is x, I mean, and now this is n. This is n minus 1, and this is x squared. We stop right here because we only need to expand until x squared term, so no need to continue. And now we simplify. Here we get 2x, simplify, here we get 4x squared, multiply everything by 4, we get the first expansion. Now for the second expansion, we have this in blue, 2 over 2 plus x, so same concept. We use 2 plus x to the power of minus 1, and this time we cannot use the formula directly, because if you want to use the formula, you gotta have 1 plus something. It's gotta be 1, it cannot be 2 or any other number. So we have to factor out the 2. Notice that if you expand, you're gonna get 2 again. If you expand, you're gonna get x again. So we're just factoring out the 2. Now remember, this 2 is also to the power of minus 1. 2 to the power of minus 1 is 1 half, so 1 half times 2 is 1. So we have 1 here, and now we can use the binomial expansion formula. This is 1 plus n times x, and this is n minus 1, and this is x squared. And we use a calculator. Here we have minus 1 half, and cancel out, we have 1/4 times 1. So yeah, we're done here. And now for the last term, we have to use 2 plus x to the power of minus 2 because of this, and we factor out the 2 again, and this 2 is also to the power of minus 2, so 2 to the power of minus 2 is actually 1/4, so we have minus 7/4. Now this is 1 plus something, we can use the formula. This is n, this is x, this is n minus 1, x squared, and this is minus 1x, and this is 3 over 4x squared, and multiply by minus 7/4, minus 7/4, minus 7/4 times. So we have all the expansion. Now we combine everything. So we just add, we get 4 plus 1 minus 1, I mean minus 7 over 4, we get this. Use a calculator. 8 minus 1 half plus 7/4, use a calculator, we get 37/4, and 16 plus 1/4 minus 21 over 16, we get 239 over 16. So this is the final answer. Okay, notice that we use minus 7 on top, so here we are just adding everything, so we do not subtract, we just add everything because the minus is here already. Okay, the second part, state the values of x for which the expansion is valid. So if you look at the binomial expansion formula, we have this rule here. So the expansion is valid only if the absolute value of x is smaller than 1. So what is the x again? The x is the one we use in the expansion formula. So in this case, the x in this case is minus 2x. So this means we have to solve the absolute value of minus 2x is smaller than 1. So absolute value of minus 2x is smaller than 1. And now for the ones in green and blue, we look at the x when we use the expansion formula. So it's not here, but it's here when we start using the expansion formula. So the x is 1/2 x, same thing here, 1/2 x. So we have to also solve one modulus of 1/2 x is smaller than 1. Yet there's no equal sign actually. So just smaller. Okay, so to solve this, first of all, here we we divide by modulus 2 both sides, modulus of minus 2. So basically we divide by 2, so we have 1/2. Here we divide by the modulus of 1/2, modulus of 1/2. So 1 divided by 1/2 is 2. So we have two inequalities, and the intersection is smaller than 1/2, also smaller than 2. So the intersection or the final answer is just smaller than 1/2. This is the final answer. Alright, I'll see you again next time.